Okay, this is a tutorial on significant figures, identifying them, rounding them correctly, and doing mathematical operations with them. You can watch this as many times as you need to, pause, rewind, any of that. After you've watched this, you'll have a practice sheet and you'll have a FIP quiz tomorrow. We know why we keep track of sig figs. We use them to show how precise a measurement is. And we started to talk a little bit about what numbers are significant when you haven't made the measurement, but you're handed a number and you have to assume that the sig figs are telling you how precise the measurement is. We said, number 1, all non-zero digits are significant. So the number 436.52 has got 5 sig figs. The number 73, 2 sig figs. 72,641.14, 7 sig figs. Not a zero, it's significant, guaranteed. Okay, well that seems pretty easy. I don't see what's so hard about this. We said all non-zeros are significant. What about zeros? Well, they're kind of weird. Let's look at the rules for zeros. Okay, we said any non-zero digit was significant. And the first rule for zeros is, if a zero is between two non-zeros, it's significant. So 406 has 3 sig figs. 7,201 has 4 sig figs. 8.02, 3 sig figs. And 10.05 has 4 sig figs. If they're between two non-zeros, they are significant. Not so bad. Okay, let's talk about another case where zeros are significant. If we have a zero that's behind the decimal place at the end of a number, it is significant. So 72.0 has 3 sig figs. 416.000 has 6 sig figs. And here's our big giant crazy one. 536.000000 has 9 sig figs. Okay. Okay, so we've talked about the two cases where zeros are significant, when they're between two non-zeros or when they're behind the decimal at the end of a number. Now let's talk about the one case where zeros are never significant. When a zero is out in front of all non-zeros, it's not significant. It's considered a placeholder. So 0.007 has 1 sig fig. 0.05 has 1 sig fig. 0.000018 has 2 sig figs. These are all placeholder zeros. None of them are significant. Notice that it doesn't matter if we show a leading zero or not. In either case, this is a number that's out in front of non-zeros and therefore it's not significant. It would be like if we wrote the number 512 with 2 extra zeros in front of it. We know these don't mean anything, they're placeholders. That number has 3 sig figs. So that's the case where zeros are never significant, if they're in front of non-zeros. Now, let's get to the one that's got a little bit of fudge room. Here's the one that is a little bit funkier. So when 0 is at the end of a number and in front of the decimal, it may or may not be significant. So, in the case of the number 750, with no decimal behind the 0, this has 2 sig figs. It's not significant. By placing the decimal here, we make that 0 significant. So this one has 3 sig figs. That's not too hard. You just have to remember, decimal means significant, no decimal, not significant. Okay, let's talk about scientific notation. Scientific notation. When we look at scientific notation, a number in scientific notation has as many significant figures as are shown here. So 5.0 times 10 to the third has 2 sig figs. 7.20 times 10 to the negative 7th has 3 sig figs. And 9.0 times 10 to the 24th has 2 sig figs. The zeros that you would add with the scientific notation are never significant. The only numbers that are significant are the ones shown here. Okay, now let's move on quickly to doing some rounding with sig figs. Whoops! First we have to talk a little bit about operations with sig figs. So, again, as there was with scientific notation, there are two different sets of rules. For adding and subtracting, we have to look at the digits behind the decimal point. So, if we add 3.2 and 5.00, we're looking at the number that has the fewest digits behind the decimal point. That will control how many sig figs our final answer can have. So while our raw answer is 8.20, this 3.2 limits us to 1 behind the decimal. So our sig figged answer would be 8.2. Okay, we've got a subtraction problem now. 11.57 minus 9.300. Our raw answer is 2.270. But if we look carefully at the numbers that go into making that answer, we notice that 11.57 has 2 numbers behind the decimal. So our answer is limited to 2 numbers behind the decimal. Though our raw answer is 2.270, our final answer for this problem should be recorded as 2.27. Okay, those are pretty simple. Just remember, when adding and subtracting, you're looking at the number of digits behind the decimal, and you're always looking for the number that has the fewest. Multiplication and division have different rules. So when we're multiplying or dividing, the answer can have no more sig figs than there are in the measurement with the fewest sig figs. So let's do a quick multiplication example. 1.5 times 2.5 gives us a raw answer of 3.75. But we can't have any more sig figs than there are in the measurement with the fewest sig figs. In this case, both 1.5 and 2.5 have 2 sig figs, so we're limited to 2 sig figs. We're going to round that 7 to an 8, and our final answer should be recorded as 3.8. Let's try a division example. 14.9 divided by 2. Well, our raw answer is 7.45. But if we look at the numbers that went into getting that, we see that 2 only has 1 sig fig. So we're limited to 1 sig fig in our answer. That 7.45 is going to just remain 7. Okay, this brings us to our next topic, rounding and sig figs. Once you've gotten a number and you need to round it, the first step is to determine how many sig figs you can have. Okay, we've got an example here. 18.389 times 2.47. Our raw answer is 45.42083. But we need to look at how many sig figs we can have. If we look at the 2.47, that's got 3 sig figs. We're doing multiplication here, so we're looking for just the lowest overall number of sig figs we've got, and this gives it to us. So we can have 3 sig figs. Alright, now we're going to start from the front of the number, and we're going to count how many numbers we can keep. 1, 2, 3. And I typically underline that last digit that I'm going to keep just as a visual reminder to myself. You're rounding this 4 based on the number that comes only after it. So you can't consider anything that's beyond that. The recorded answer for this will be 45.4. If you look at the next number and it's between 0 and 4, it stays the same. If it's between 5 and 9, we round up. Had that number been 45.48083, we would have rounded that up to 45.5 based on the 8. Okay, you got that? Now let's try some weird and tricky rounding with sig figs. Okay, assuming that you've been given this number, 73,079.14, and you've been told that you need to round it to 6 sig figs. Well, this isn't too hard. 1, 2, 3, 4, 5, 6. We're going to keep that number. And if we look at the number that follows it, we know that it won't round up. Okay, that was pretty easy. 73,079.1. Now let's say that you've been told that you have to get this number down to 5 sig figs. Okay, 1, 2, 3, 4, 5. Great, we're keeping the 9. Because if we look at what comes after the 9 in the original number, it's a 1, so that will not round up. Remember, in a case like this, you always have to look back at your original raw number in order to determine what rounds and what doesn't. Now, let's say that we've been told we can only have 4 sig figs in our final answer. So our original number has to go to 4 sig figs. Well, 1, 2, 3, 4. That's the last number we can keep. Okay, 7, 3, 0. Well, that 9 is above 5, so that'll round to 8. Are we done? No. That would change our number drastically. We have to put in a placeholder 0. So what we're saying is that as precise as we can be is 73,080. Now, let's imagine that we've been given that number and told we need to get it down to 2 sig figs. This sounds difficult. It's not. Okay, we're taking this to 2 sig figs. So that 3 is the next thing we're going to keep. We have to look at the number after it. It's a 0, so we know this won't round up. 73. Is 73 the same as 73,000? No. So we have to put our placeholder zeros in. And our final answer here would be 73,000. That's as precise as we can be. If you look at the example in your notes, it should help you. Let's do one more tricky one with doing sig figs and very tiny numbers. Okay, we've got this number, 0.0008745, and we've been told that we need to have 3 sig figs. Here's the mistake many people make. They start counting here and go 1, 2, 3. Oh, I should have 0.001. No! You start counting from the first significant digit in a case like this. So you're going to start counting from the 8. 1, 2, 3. You can keep this number and you'll round that 4 based on the 5 behind it. 0.00875. That's a lot more precise than this number. Don't make that mistake. Okay, using the notes, your book, and this tutorial, you should easily be able to complete the additional homework or the additional practice problems that you've been given. Good luck, and I'll see you tomorrow.